Right, in 2015 question 7, trigonometry and area question. So a flat machine part consists of two circular ends, here and here, as shown. The sides of the circle HK and PK, HK and PK are tangents to each other, so they just touch the circle at one point. Once we know that there, that indicates this right angle. That's what the tangent's telling you, it's a right angle. The smaller circle is centre A and radius R. Or the larger circle is centre A and radius 4R, and the smaller circle is centre B and radius R. The length of HK is 8R and AB is 20 root 73. Find R, the radius of the smaller circle. So we're looking for this. Now here they give you a clue. Obviously we're going to use hint, draw BT parallel to KH. That's what the M lines mean there, parallel. So there's KH. We're going to draw B. Now it doesn't tell us where T is, but here it says T is an element of AH. T is an element of AH. There's something on here. And since it said parallel to this, they want you to form, as you can see here, is a rectangle. If that's 8R, that's going to be 8R. There's our T. If this is R, this is R. So we have a rectangle up here. And now we have our right angle triangle. Now just be careful, if it's R up here, the whole thing was 4R, the radius, and we've got R, that means that this here must be 3R. Now to find the radius, we'll work out the value of R, and we can do that using this wee right angle triangle. Can't really use the rectangle, we can just work out the area of the perimeter in terms of R. So here we have a right angle triangle. A, T, B. This is 3R, there's a right angle, 20 root 73, and T to B is 8R, the opposite end of that rectangle. Now apply Pythagoras, since it's a right angle triangle, so the hypotenuse squared, 20 root 73 squared is equal to one of the sides squared plus the other side squared, added together. 20 root 73 is square 400 times 73. 20 root 73. 29200. 3R squared is 9R squared plus 64R squared. Add these two together. 73R squared. 5 by 73 now. 400 is equal to R squared, and then R is the square root of 400, which is 20. So if R is 20, that implies that 3R is equal to 60, just when it's in my head, and 8R is equal to 8 times 20, 160. So you can always fill those back in. So that means this here is 60, and there's 160. Now, the second one. Find the area of the quadrilateral ABKH. So ABKH. As you can see now, it's made up of two shapes. You have your rectangle and your right angle triangle. So say we wanted to work out the area of that right angle triangle. The right angle triangle is half the base by the perpendicular height. So our base here is your 3R, which is 60, and our perpendicular height, straight up height, is 8R, and we worked out R to be 20, so 160. So a half the base times 160, 4800. What's that, centimetres squared? Say the units in centimetres. Now to find the area of the rectangle. So a rectangle here being AHT KB. You've got 8R. 8R, as we mentioned, is 160. And R is 20, so area is equal to length times width. 160 times 20. 3200 centimetres squared. Therefore the total area, add them both together, 8,000 centimetres squared. Next one. Find the size of the angle HAP. Now H to A to P. What we've been working with is the upper side of this figure. So if we worked out the area of this here, we can just simply double it. So we've got our right angle triangle. I'm just going to work with TAB. TAB is the same as HAB. So TAB. TA is 60. AB is 20 root 73. There's our little right angle up there. And TB is 160. So we want to work out this angle here. Right angle triangle, so we can apply sine, cos or tan. So opposite me here is 160. Hypotenuse is 20 root 73. And adjacent to 60. So you can apply any of the triggered entities, sine, cos or tan. In order to find the angle, it's either going to be sine inverse, cos inverse or tan inverse. So if it's sine, use O and H. Sokotoa, Oliver had a handful of apples, silly old Harry, whatever one you want. So sine inverse of 160 over 20 root 73. And just make sure your calculator's in degrees. And you get 69.44 degrees. Now that's for TAB, therefore to work out HAP, you double it. 138.88, one decimal place, 138.9 degrees. Now as I say, you could work out or use any of the sine, cos or tan and you should get the same answer. And then the last one, find the area of the machine part, so the total shaded area. We worked out the area of the quadrilateral. So the two quadrilaterals there is just going to be double it. So area of two quadrilaterals is 8,000 by 2, 16,000 centimetres squared. Now you've got the small matter of your small circle and your larger circle. Now keep in mind, why would they have wanted you to do this? If in doubt, use your previous answer. So we've got HAP to be 138.9. Now if you look at your small circle, you've also got the same angle. So this is your 138.9 in here. In here, 138.9, same as what you've got in there. That's just a circle, so the area of the circle is pi r squared. This isn't a full circle, so just put the fraction of the circle at the start by pi r squared. So area is 138.9 over 360 multiplied by pi, multiplied by the radius squared, and the radius is value of r, so by 20 squared. And you get 484.85 centimetres squared. I wouldn't round too early, you can do the round at the end, since it says the near centimetre squared. And now just a matter of the large circle. The large circle, obviously it is in 138.9, but to get the area of this, it makes up a full circle, so 360 degrees minus 138.9. Is 221.1 degrees. To get the area of this circle again, it's 221.1 over 360. Multiplied by pi, multiplied by the radius squared. Now the radius of this is 4r, so 4 by 20 is 80 squared. I'll just put that in your calculator. You get 1, 2, 3, 4, 8, 2, 4, 8.55. Just add all up. When you do that, 5.5 plus. You get 288.34 centimetres squared to the nearest centimetre squared, 288.34 centimetres squared.